Good morning, guys. Today we're going to work with SPI 3.14. That's binomial expansions and binomial probability. What that entails is things such as this example right here, where it talks about expanding a binomial. That means we're adding or subtracting two terms, two expressions. Now, typically when we think expand, that means multiply this expression out that many times. So I would take 3x minus y squared, write it out 10 times, distribute 10 times, and go through and get your big, long 11-termed expression. They're not going to ask you to do that on EOC. What they really want you to do usually is find either one term or the coefficient of one term. So that's what we're going to go over, is how to find just a specific piece of the expression instead of the entire expression. All right, so let's look at this one. What's the coefficient of the sixth term in the expansion of the quantity 3x minus y squared all raised to the 10th power? Well, as I go through this, a couple of key words that I should see are expansion, okay? So that means multiply everything out. And then I've got to recognize it's a binomial. So as soon as I see expansion and binomial, I think binomial expansion. There's my two terms. They gave me the expansion. In which case, I go to binomial theorem. Well, how do I remember that this is the binomial theorem? Well, on my reference page, I can see right here on the very first page, towards the bottom left side, we have the binomial theorem. This means to take a binomial raised to some power. We're just going to plug it into this formula. The big Greek sigma, that just means do this a bunch of times and add all those values together, which we know that's what we get anyways when we expand binomials. Some expression plus another plus another plus another. So that's what this means. You're going to get the same pattern for your expressions, and then you're going to add them all together. So let's go through how do we do that. So we start out by looking at this expression. Now, nobody uses this parentheses n over r thing anymore. Well, almost nobody. What we usually use is NCR. So I'm going to eliminate this parentheses n over r, and I'm going to change it to NCR. And the reason I want to think of it as that is because that's a button on the calculator, a program on the calculator, so we can get that value. This means the same thing. I have this many items, and I'm picking groups of R. So that's a different set, different SPI for a different day. But right now, when we see this on the reference page, we want to replace it in CR. So that's what we get right here. These are the individual terms. This just means executed a lot of times, added up. So how does that tie into the expansion that we've got? Well, to get the first term, we're going 10 times. See, n is 10. N is 10. So that means we want to go 10 times. Okay, so 10c, and then you just, right here it says start at 0. So for the first term, it's 10c0, and then 10 minus 0 gives me an exponent of 10. R is 0, gives me an exponent of 0. I don't care about the first term, though. I'm just establishing a pattern. Second term, 10c1. Now, 10 minus 1 decreases me by 1. Well, if my whole thing has to be powers of 10, 10 and 0 is a power of 10. 9 and 1 gives me a power of 10. So we're just going to keep going through, keeping that power of 10. So the third term, 10c2, and there's my 8, and there's my 2. Fourth term, 10c3. So I'm still decreasing by 1 every time, increasing by 1. Overall is 10. So we've just established a pattern. There's the fifth term and the sixth term. This is what we want to get to. 10c5 to the fifth and to the fifth. So n minus r, so 10 minus 5 is 5. And then we have 5 for the other exponent. The r is 5. Now, they asked me just to find, if you'll go back to our question, they said find the coefficient of the sixth term. Coefficient is going to be the 3 and the negative 1. So it doesn't say find the term. If it said find the sixth term, we plug the x's and y squareds in and everything's good. I want the 3 and the negative 1. I want the coefficients of those variables. So we're down here, and we've plugged in our coefficients here. Well, how did I know to do that? Because a and b are what we're adding together. A and b are the base of those exponents. So 10c5, 3 to the 5th. And I just punch this in the calculator. Grab my calculator. Now, 10C5, remember the whole point of changing it to NCR is because I have that on the calculator. So I'm going to do parentheses, just like I've got parentheses right here. 10, and then where do I get my C? Right here, I hit my math button. I go over to PRB because NCR is a probability thing. So I go math, probability, and you can see right there, choice number 3 is NCR. So I have 10 NCR 5. So 10 C5, and you just finish filling it in. Parentheses 3 raised to the 5th, parentheses -1 raised to the 5th. Make sure you're putting these in parentheses so that your exponents and negatives get straight. And we hit enter, and what do we get? 61,236. When I hit enter, 61,236, and if I go back to my original question, -61,236 is choice B. So I didn't have to sit here and multiply this thing out 10 times. I had to recognize a couple of few words, expansion and see a binomial, and then know I've got to go to my reference page to get the formula and just start plugging in the numbers in the pattern until we get the 6th term. That's binomial expansions. Now let's look at another ways to use that binomial theorem. Dirk is packing his bags for vacation. Of all his t-shirts, 30% of them are white. If he packs 8 t-shirts, what's the probability that exactly 3 of them are white? So what they're doing here is they're asking us a probability, but they've already given us a percentage. Percentages and probabilities are interchangeable. So they've already given us a probability of what all of his white shirts are. So let's look at in just these 8 shirts. So it's still going to be binomial probability because there's 2 scenarios. He either has a white shirt or he doesn't have a white shirt. So that's 2 scenarios. So binomial probability is when there are only 2 possible outcomes. White shirt or not white shirt. And the way we calculate that probability of exactly our outcomes from n trials is this right here. Well, this should look familiar to us because this was the way we got our individual terms right here. Okay, individual terms is actually the same thing as individual probabilities. So individual terms and individual probabilities are going to be the same thing. For binomials, that's 2 possible outcomes. So we're finding the probability of exactly 3 white shirts from 8 total shirts. So we just plug in the numbers. 8C3, okay, NCR. Our outcomes, that's 3 shirts in trials. Trying 8 shirts. So we've got 8C3, and we just plugged in the numbers. N minus R, 8 minus 3, and 3. Now, this 3 white shirts, well, the 3 white shirts go with the 30%. So 30%. Well, what goes in that other set of parentheses? The rest of it. Remember, we said it's either white or it's not white. So if 30% are white, the rest of your percentages, 100 minus 30, which is 70%, would have to be not white. It doesn't ask about lots of different colors because they give us two options, white or not white. That's what makes it a binomial probability. So that's 70%, and we just cleaned up 8 minus 3 is 5. Now we should see it starting to look like some of our choices. If I convert my decimals, my percents into decimals, 0.7 to the 5th power is what 70% to the 5th. Well, right here, I see 70% to the 5th and 70% to the 5th. So 2 options are already gone, and I haven't had to do any math yet. I just read a problem and plugged it into that formula that's on my reference page under Binomial Theorem. 30% has to be at 3. Well, that matches for both of these. 30% is 3. Now, what's the difference in these two? This one doesn't have a coefficient other than 1. This has a 56. So I need to look at this 8C3. If it comes out to be 1, A is my answer. If it comes out to be 56, D is my answer. Well, how do I figure out which one it is? I go to my calculator, and I just punch it in the calculator. I'm going to do 8. Where did I get my NCR? I went math, PRB, C, 3. 8C3 is 56. So we can see that it's 56 times 70, sorry, 0.7 to the fifth power and 0.3 to the third power. So it matches choice D. I didn't have to figure out what the actual probability was. They just really wanted me to set it up. Now, guys, that is binomial expansions, binomial probabilities. Got to recognize the scenario. They won't use the word binomial, but they'll either give you a binomial with an exponent, binomial expansion, or they'll describe a probability where you have either one thing happening or another thing happening. There's only two possible outcomes. So that's binomial expansions, binomial probabilities. Both of them are going to use the binomial theorem that we had on our reference page. So look for those key things, and you should be able to easily get these problems solved. See you in class tomorrow.